Class, welcome back to our next video on graphing trig functions, and today we are focusing on the last two, alright, tangent and cotangent. So to get started, we're going to make sure that we have our sine and cosine values, or y and x values, for the quadrantal angles. Alright, so we have 1, 0, 0, 1, negative 1, 0, 0, negative 1. And then I'm actually going to add my pi over 4s as well. This is something that you are not going to have to do on your graphs, but I think, and I'm hoping it just helps. And you know what? So I'm just going to say this is root 2 over 2, root 2 over 2. Over here would be negative root 2 over 2, root 2 over 2. Negative root 2 over 2, negative root 2 over 2, and then finally positive root 2 over 2 and negative root 2 over 2. Okay, so I'm going to add those just to kind of hopefully prove a point in a little bit. All right, well, we have to remember that if we're trying to graph tangent, tangent is either sine over cosine, or another way, of course, we can think of it as y over x, right? Y over x. So that means we need to go and we need to find the tangent values for everything. We need to find the tangent values at every location, all right? So when we take the tangent of 0, well, y over x, 0 over 1. This is just 0. All right, I'm gonna go around to the quadrantals first, and then I'll come back to the pi over 4s. How about straight up? Tan of pi over 2. Well, y over x, 1 over 0. Ooh, undefined. Can't do it. Over here, straight to the left, tan of pi, that would be 0 over negative 1, so again we're at 0, and tangent of 3 pi over 2 is equal to, well, negative 1 over 0, undefined again. Alright? Okay, so now we have the quadrantals. What I want to do is I also want to take care of these pi over 4s to hopefully prove a point to you. Alright, I want to try to prove a point so that we can get this, we can figure this one thing out, and then we won't have to worry about it again. Alright, when we do tangent of pi over 4, well, root 2 over 2 over root 2 over 2 completely cancels. This is 1. When we're up at 3 pi over 4, so tan of 3 pi over 4, excuse me, we have y over x. Well, this is just going to be negative 1, right? Y over negative, perfect. Down here at 5 pi over 4, we have a positive 1 again, right? A negative divided by a negative is positive 1. And then lastly, at 7 pi over 4, we're back at a negative 1, right? A negative root 2 over 2 over a positive is negative 1. All right? Now, the reason I did this is because I want to prove to you, or show you now, the period's a little different. All right? With sine, cosine, cosecant, secant, the period was always 2 pi. It always took one full rotation to go through an entire cycle, to go through one cycle. All right? Well, let's take a look at these values that we just came up with. We start at 0, we go up to 1, we hit an undefined, then we're at negative 1, and then we're at 0. And then it repeats itself, right? 1, undefined, negative 1, 0. All right? So I am here to tell you now, and hopefully you guys can see it with these points, that these points down in the bottom half, these are just a repeat of the top half. Point being that one period, if we slide down here, one period for tangent and cotangent is pi now. It is no longer 2 pi. It does not take a full rotation to complete a cycle. It's just pi. Half of it. Okay? So that's important. Now, what that kind of tells me also then is that, well, how many quadrants are in pi? There's only 2, right? I only have 1 and 2. So does that mean I have to divide by 4 when I'm trying to find the sections? No, I only need to divide by 2. So that's a huge difference between tangent, cotangent, and then all of our 4 that we've already been practicing and getting good at. We only need to think about tangent and cotangent, as pi being the period and only 2 sections. So what is that going to look like then? Well, when I go to graph tangent here, I know I have a point at, or I have a dash, a tick mark at 0. I'm going to have one at pi over 2 and pi. Those are my 2 sections. And then of course, just like we were doing with sine cosine, if I go 2 sections to the right, I also want to go 2 sections to the left. Alright, now let's think what this is going to look like. At 0, I had a point. At pi over 2, I should label this, my bad guys, pi, negative pi over 2, pi, negative pi. Alright, so now I have everything ready to go. At pi over 2, I have a asymptote, right? Because it was undefined. I should probably change colors. I'm just a mess today. Sorry, guys. I'll get better. Alright, and then at pi, I had another 0. And what happens then? Well, everything gets repeated. Or you can really think about it, if I want negative pi over 2, that's just down here at 3 pi over 2, so I'm undefined. And at negative pi, I'd be over here, so I have another point. Alright, so now I have everything ready to go. At this point in time, I'm not worrying about my pi over 4s anymore. I mean, you could, I guess, place them, but that's just going to make your graph super messy. What I want you to think about is between 0 and pi over 2, is the tangent positive or is it negative? Right here. It's positive. We can use this as a hint, or we can remember that we're plus plus in quadrant 1. So what this is going to look like is kind of an S. Alright, one of these guys. When we are in quadrant 2, our tangent is negative. So it's actually going to look the opposite, or something like this. Alright? So that is a full period of a tangent curve. That is one full period. Now, we do have to repeat. You can think about this in 2 ways. You can just remember that this is going to continue down, because it's going to kind of look like a cubic or an S-curve. Or you can think, if you're going down now, right, if you're going negative in a negative angle, you're down here in quadrant 4. Yeah, well, tangent should be negative, so we'll do one of these. And then over here, we would be up like that. Oh, that was not the best, but hopefully you get the drift. Okay? So this is 2 full periods. This is 2 full periods. This was our first period. This was our second period. We are now done with our tangent curve. So things to keep in mind, and we'll point this out a little bit more when we get to the cotangent. You're starting at a point with tangent, so it goes point, asymptote, point, point, asymptote, point. Alright, keep that in mind because it's going to switch right now. What I'm going to now do is right below my tangents, I'm going to get all the cotangents as well. Alright, so let's come back up here. Cotangent of 0. Well, now we're 1 over 0, right? It's x over y. Cosine over sine, x over y. So the cotangent of 0 is now undefined. Cotangent pi over 4 is still 1. Cotangent, oh, I'm running out of room, pi over 2 is equal to, what's that? X, okay, now we're at 0. Cotangent 3 pi over 4 is still negative 1. Cotangent of pi, I believe, is undefined, right? X over y, yep, undefined. And then we can go through it again. So cotangent 5 pi over 4 should be positive 1. Cotangent of 3 pi over 2 should be 0. Yep, 0 over negative 1, perfect. Last one. Cotangent 7 pi over 4 is equal to negative 1. Alright, so once again, we notice, and I know it's getting a little sloppy, but if you can try to look at the purple, I go undefined, 1, 0, negative 1, back to undefined. So just like tangent, I only need pi for my period. I only need half of a circle, not the full circle. which means when I come down here and I label, I only need 2 sections to the right and 2 sections to the left. So pi over 2, pi, negative pi over 2, negative pi. Now, let's think about the differences here. What's happening? For cotangent, I'm starting at undefined, which means I'm starting with an asymptote. Up at pi over 2, I have a 0, and over at pi, I'm undefined. So let's just get this out of the way right now. Oh my gosh, I'm off the graph. You guys are going to kill me for that. Sorry. In tangent, it was point, asymptote, point. Cotangent, asymptote, point, asymptote. All right? Please remember that. It is important. All right. So now let's finish this up. Please remember, we just want to kind of figure out the sign of this graph in the different quadrants, right? So from 0 to pi over 2, my cotangent is positive. All right? So if it's positive, it's going to do one of these. And then in quadrant 2, it's negative. So it's going to do one of those. And then, of course, I want to draw a second. So something like that. So do we see the differences here? First things first, tangent looks like it's going opposite of cotangent, right? This looks like a normal s curved or x cubed. This looks like a negative x cubed. But what I want you to understand, the one period, that's pi, it's one branch, right? Something like that. Just one of them. All right? Okay. Let's see. Let us skip the bottom part for right now, okay? Let's skip this bottom part for right now. I want to move on. I want to start graphing some of these with you. All right. So, we've already taken care of some of this stuff up at the top. All right? To calculate the period for tangent cotangent, well, we know the normal period for tangent cotangent is pi. All right? So, if we want the period, just like what we were doing with sine, cosine, secant, blah, 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 it's still pi over absolute value of b. All right? We're still going to divide that by b because b is still that kind of horizontal shrink or stretch. All right? The b value, that is. All right? However, we know that we only need to divide the period into 2 sections. And again, why was that? Because if the period is only pi, that's only 2 quadrants, all right? Remember when we talked about the 4 sections being the 4 quadrants? Well, that's why it's only 2 sections now, because it's 2 quadrants. The a value is a little different here, okay? Well, I guess not really. The a value we don't call the amplitude for tangent cotangent. We just call it the vertical stretch shrink. And I will show you what we do for that in a bit. All right? Okay, so let's jump into it. Let's think about this, okay? So we're talking about tangent. My b value is 7, which means then that my period should be pi over 7. Pi over 7. All right. For the section, I do pi over 7. Either divide it by 2, or we can always multiply by 1/2. Sometimes that's easier, so that would be pi over 14. And then we still count off by the sections, right? So here's section 1, or section 1, section 2, section 1, section 2. And we count by the sections. So if this is 0, this is pi over 14. Well, 2 pi over 14 is pi over 7, which is exactly what we wanted, right? That's our period. And then, of course, we go back the other way. Negative pi over 14, negative pi over 7. All right. Okay, we're ready to go. This is a tangent. So again, the quicker that we just kind of think about, well, you can always think about this and kind of, I don't know, you don't have to memorize this stuff. You can use a unit circle or your knowledge of the unit circle to get this every time. But if I'm talking tangent, then I know it goes point, asymptote, point. Point, asymptote, point. Point, asymptote, point. Okay? Now here's what we're going to ask you to do to show the vertical stretch. What I want you to do, I'm going to want you to kind of dash an original tangent, okay? So an original tangent I know in quadrant 1 is positive, quadrant 2 is negative. So I would do something like this. Alright, that's kind of my normal. And then if there's a vertical stretch of 5, well that means that I have to take every point and stretch it out, right? Stretch it out. So that means my curve would look something like this. Okay? Hopefully that makes sense. And this is all I need to see to show me that there's a stretch. If you show me a dashed normal curve, or the normal tangent, and then I know there's a stretch of 5, well then that's just going to be stretched out a little bit everywhere. Okay? Cool. Alright, let's take a look at the next one. The next one, I see that my b value is 3, so that means I should have pi over 3 for my period, of course. And then again, the section, you either divide by 2 or we multiply by 1/2. So pi over 3 times 1/2 equals pi over 6. I think that looks good to me. All right, we do the same sectioning. 1, 2, 1, 2. This is pi over 6. This is another pi over 6, so 2 pi over 6. But of course, we would write that as pi over 3. We come back the other way. Negative pi over 6, negative pi over 3. All right. Now, again, until you feel comfortable with this, think about the unit circle. Cotangent is x over y. 1 over 0 is undefined. That tells you that right at 0, or your starting point, you have an asymptote, which means you're going to switch to a point, and then you're going to be back at another asymptote to finish the cycle. And then, of course, asymptote, point, asymptote, because it's the exact same thing on the other side. All right? Okay. We got to think about this now. We don't have an a value, so we don't have to do any dashed curves. We're ready to graph because there's no real stretch, but there is a negative. Okay, there is a negative. Now, if we remember, normally cotangent is positive in quadrant 1 and negative in quadrant 2. But if it flips, hopefully you understand that we're just going to flip from positive and negative to negative to positive. All right, so I would come over here and I would go S, that's not great, but it'll work, and S right there. Okay? Oh man, okay, we're getting there. We're getting there. 2 more graphs. I'll try to go a little quicker. This is a little bit closer to what you'd see on a quiz or a test because it has our information that we need about period, domain, etc. But we got this. We can do this. This is not bad. All right. So, period. We know we want to do pi over b. Okay? Now, instead of doing pi divided by a fraction, please remember you can always do pi times the reciprocal of b. So I'm going to multiply by 3/2, which means that my period is 3 pi over 2. Well, my section is the period either divided by 2 or multiplied by 1/2. So my section should be 3 pi over 4. All right. Now we're ready to plot this thing. This probably is too big of a line, but whatever. It'll be okay. All right. I can section. Boom, 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 boom. I count the sections. 3 pi over 4, 3 pi over 4, which means this is 6 pi over 4, right? It's the same gap. So 6 pi over 4, but I'm going to rewrite that as 3 pi over 2. What do you know? We're good. Other side. negative 3 pi over 4, negative 3 pi over 2. Cool. We're talking cotangent here. So until you feel comfortable, think about it as x over y. X over y. Well, x over y at 0 is 1 over 0, which is undefined. So that tells me it's undefined at the start. Point. Asymptote. Point. Asymptote. All right? So that's good. Next thing we need to think about here, well, we know this is going to be negative. All right, so normally a cotangent would go positive quadrant 1, negative quadrant 2, but what? But we know that because it's negative, it's going to be flipped. So I'm going to go negative to positive, and I'm going to dash it. Why do I have to dash it? Because I also have to show an amplitude or a vertical stretch shrink. All right, so I'm going to dash this original. Not the best. Yikes. Getting better and better at these. So I dash this. And then because this has a shrink of half, that actually means I need to get closer. All the points need to be shrunk down closer to the x-axis. So I'll do one of these. Get closer and closer. Closer and closer. Something like that. Okay? Great. Now we're ready to kind of come up with domain stuff. All right, so domain here. Well, just like with secant and cosecant, like we say that it's all real numbers, and then we have to give the restrictions. So the restrictions are all the asymptotes. Our first asymptote is right here at 0. And we know we're going to have to add or subtract from it. And let's see here. Well, we have to add or subtract 2 sections, right? That's where the next asymptote is. So 2 sections is 3 pi over 2. So 3 pi over 2n. For range, let's think about this. It goes down forever. It goes up forever. There's never a place where it doesn't equal a y value. So you can either give me all real numbers, or you can say negative infinity to infinity, your choice. Asymptotes, well, we kind of already did the asymptotes, right? We know the asymptotes are at 0, 3 pi over 2, negative 3 pi over 2, and you just keep adding those 2 sections. So x equals 0 plus 3 pi over 2, n, and here's where this is trickier than secant, cosecant. Usually with the cosecant, secant, it was one or the other. For tan and cotangent, you have both. Okay, so we have zeros at 3 pi over 4. So that's my first one. X equals 3 pi over 4 plus or minus. And, well, there's not another one over here, but we could go backwards and we can see it's still 2 sections. And we can either slide that and see that our 2 sections is 3 pi over 2, or understand that the asymptotes and zeros are going to have the same rules, right? So this will be 3 pi over 2n as well. Okay? Okay, one more. I know this is taking forever. Oh my gosh, I'll try to speed through this one as best as I can. Oh, I'm killing you guys. I'm sorry. I talk too much. Okay, let's get through this. Period. Pi divided by b, which is 1/2, but instead of dividing by 1/2, I'm going to multiply by the reciprocal. So, what do we have? 2 pi? Yes. Which then means my section will be 2 pi divided by 2, which of course is just pi. Alright, this is good. Draw our graph, make our sections, so there's lots of space, and count off the sections, tick for the tick marks. So that's a bad pi, but pi, 2 pi, negative pi, negative 2 pi. Okay, we know this is tangent. We think of tangent, which is y over x, and we think about that first point, which is 1, 0. So 0 over 1 is actually 0, so we know we're going point, asymptote, point, point, asymptote, point. Alright? Have to keep in mind that there's a couple of things going on. First things first is it's flipped. and there's an amplitude change, or not an amplitude, excuse me, vertical stretch. Okay, so first thing we have to do is we have to dash a negative tangent. All right, I want to dash a negative tangent. Well, normally tangent in quadrant 1 would go positive. So that means if it's flipped, excuse me, it's going to go negative. So I would dash something like this. Dash, 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 which then means on the other side it would be positive, positive, and then of course we'd finish negative. All right, so there is our original negative tangent curve, and the last thing we have to do is show this amplitude change, show that it's stretched out. Okay, so we do that by making sure our graph is above or stretched bigger than what we have here, which means I need to do something like this. Oh, this is not great, but it'll work. All right, something like that. And something like that. Okay? So that shows me that it is stretched, and now we're ready for domain. We know we say all real numbers, but x cannot equal those asymptotes. So our first asymptote was at pi, and it's 2 sections. So was the next one. So pi to negative pi. Well, just move the 2 sections over. 2 pi. Let's think about the range. Oh, what didn't we say? Range is always going to be all real numbers for these. That's good. That's easy. Asymptotes, we already did, right? We already did the asymptotes. X is equal to pi plus or minus the 2 sections again, the 2 pi n. And then zeros. Our first 0 is at 0, so x equals 0. And we have to add or subtract 2 sections, or 2 pi n. Alright, so there is cotangent tangent. Hopefully you guys are understanding it, and of course we will practice and talk about them in class tomorrow. Have a good one.